So minimum requirements. I usually either say requirements or minimum requirements. Requirements means this is what it has to do. Does that mean that that's all it should do? No. You're always invited to be creative, go beyond and do things, because the real learning starts when you go beyond what I've assigned you and work on your own little projects and assemble robots. Like 2/3 of Team Tier is here. They've been having a lot of fun and you've learned a lot from that project. We are going to create an OOP, object-oriented program, that calculates the cube's volume and surface area, and I even give you the formulas. Look at that. Whew, that's too easy. Oh, I give you a to-do. Well, I practically did the program for you, didn't I? Right? Yes? No? Rashawn, he's shaking yes. How about you, Eliza? Did I practically give you the answer?
When I see the answer, it doesn't really make sense to me unless I have to do it by myself.
The whole thing?
Yeah.
Well, let's go through how to use a to-do to create a program. Because theoretically, this is something you use ahead of time, or if I'm creating a new program, I'll kind of go through and sketch out what I want to do here, what I want to do there. So I'll just call this cube.py, cub.py, cube.py. So I've outlined the program. In my programs, I always put this little stuff up here. Sometimes I put created because sometimes I look at that and think, wow, I did that 10 years ago. So do we need this when we're starting out? No. But we know we are going to need to calculate the volume. We know we're going to need to calculate the surface area, right? Because those are two of the things in the requirements. It says right here, volume, surface area. We know we're going to need that. Now we have to have some way to display the results, and this really, oh, I didn't change this. It really shouldn't be, it should be our other thing we've been doing. It should really be that. It returns the results, and then you display it. I'll change the one that's in there. I'll change the to-do code, because that's a better way to do it. So we would use str because that's what we've been learning, and that's really a better way to do it. Then it makes it very easy to make a tkinter program from it. So this method returns a string, because we've done this, representation of the object, which would be the answers. The surface area and what's the other one? Volume of the cube, right? So we have two calculations. We're going to display the answer. You don't have to do any of this. You don't have to initialize anything. But somehow from here, we have to get the user input for the edge length as a float. So how do we do that? Well, how do we do that, Eliza?
You have to create you do like user is equal to input and bring the float. The input is called.
We put float around the input. That's right. And we'd say, which one are we doing? Edge? No, we're doing the edge. Edge length. That's all we need is the edge length, because we're, it's a cube, so it's always going to be like a square. Enter the edge length of the cube. Correct. And since I'm having them enter the edge length, I'm going to call it edge length. Now we're in our main part of the program. All we're going to do here is call cube methods, display things, create our object. All the work is going to happen up here. So somehow we have to get this from here up to our object, into our object. And one way to do that is to pass it with the init. When does the init function run? When does the init function run? Christy, Owen, Sean, Hope, when does the init function run? Go ahead, one.
When you call the variable or the class for the first time.
Yep. So if we go down here where it says we've got our input, create a cube object. So did I do cube? Yeah, I did cube. So here's our cube class. How do we create a cube object from that class? Christy, Sean, Hope, you're next. Call it in the bracket thing. Sean, you remember?
Oh, there.
That's the nice thing about Python is creating an object is that simple. It looks like you're assigning this class to here, which is what it's doing, and that's what it looks like, and that's what it's doing. This object contains all the methods and everything that's inside the cube class. But you can't run a class all by itself. You have to have an object to do something with it. If we run it at this point, we still have at this point no way to get edge length into here. However, if we add an argument, we can pass it in when we create our object. And we would do that by putting it in here. Edge length. So we create our object, this value, not the variable itself, the value gets passed up to here because this is the first thing that fires when we create an object. This value gets passed to this. This gets assigned to the internal variable that is inside the class. So now we can use this variable anywhere. We don't have to pass any parameters. The only time you pass parameters is when you want to bring something in when you create it. We could also use a set method, which we've done before. Have we done this one before? I don't know if we have or not.
We did circle.
Right, but I mean, bring it in with the
Oh,
init.
that method.
I don't remember if we did or not. Anyway, if we haven't, this is one way to introduce it. So you can either do that, or what we've done in the past is set edge length, right? And this is self. But we still have to have a parameter coming in because we're bringing something in from the other side. The only difference between calling this function and calling this is this one happens automatically when the object is created. This one we have to call it manually and say set edge length, pass in the parameter, and then we do self.edge length equals edge length. And there's no reason we can't have both. If we want to change the edge length as we're running our program, this is how you would do it. If we didn't have this, you could just pass it in like this without having to use this. So in effect, these both do the same thing. You're getting information from outside the class, bringing it into the class where we can work with it. So that's called encapsulation. That's why I'm putting my hand up like this. Because everything you need to do with a cube is in here. We could take this cube class, anywhere we need to calculate a cube, we can use it, anywhere. And it's all connected together and tied together in a neat little bundle. Well, I'm not going to use this, but I could. So when I create my object, I'm passing in whatever I've typed here, I create my object. Now it says, if I do that, what's going to happen? If I don't do anything else, it's just gonna be a very dull program. I'm not calculating or anything. Nothing's happening. I'm not getting an answer. Why am I not getting an answer? I have all these methods up here.
We haven't got, yeah. You're passing over.
Yep, I didn't call the methods. So we have to use cube dot. And then notice we have all our little methods here now. Calculate, which I don't remember which one's first, it doesn't matter. So now we're calculating the surface area. Because the order doesn't matter, because we're not going to display things until both of these are done. Calculate volume. But is anything still going to happen? No. Because I haven't done this. I haven't actually calculated anything. When you're outlining a program, you can stick pass into here so you can test it as you go. And you've already got it built up, and then you come in later and fix it up and make it work. So I try to, as much as I can, put in the formula that I'm converting here so that I can figure out what I'm doing. So V would be volume. E would be the edge length, and in text you can't do superscript, so this would be E, not squared, but what's the next one?
The third,
What's it called?
the cube, no,
E to the third power. Yeah, E to the third power, that's what it is. Or E equals edge length. So how do we convert this? Well, we know one of the things that we're going to have is volume, right? So now what's our calculation going to be? We need to do our calculation with the edge. We're going to have volume as the result. So where do we get our edge value from? Hope and Christie, I still haven't heard from you guys yet. Oh, I did hear from you. Yes, Christie, you're up. Nothing? That's fine. You don't have to have an answer.
I was trying to think of something that you could put there, but I can't really do it. If I have it.
Here's our formula. So we calculate and assign that value to this. So instead of V, I put in volume because it's customary in programming to use words like this. This is not the math formula. That's more of a programming and interpretation of it. So E is edge. And so how would I take my edge length to the power of 3? What's the first thing I might do? How do I get my edge length?
Edge length times 3. Edge length.
But what else is with edge length? You're missing a part to make it work. If I just do edge length, is that going to work? What am I missing?
Oh,
Go ahead, Owen.
so,
You don't have to raise your hand. You can blurt right out. Self means that wherever I've gotten this value, I can access it anywhere in my method. I don't have to pass anything anywhere. The only time I have to pass a parameter is to get something from the outside world in. Now I can use self.edge length anywhere I want, and probably nobody remembers how to do power. I have to find the little character. It's like a
it's
caret.
It's 2 asterisks.
Oh, is it two? No, that's a square, isn't it? 2 asterisks?
Well, you do 2 asterisks and then the number you want to square it out.
Oh, okay. I'm thinking of MATLAB then maybe. Now I can't find my asterisk. It's dark up here. Will that work, you think? Well, we have no way of knowing. But you could do some print debugging. What's print debugging?
the volume to see if it.
Yeah. Find an online calculator, print the volume, see if that's right. You never know. But we do want to take this guy out. So let's see if we can figure out if we got the volume, because you don't have to do the whole program and then go back and troubleshoot 8 different little places. Figure it out as you go. Well, if I have the length of a cube is 10, it should be 1,000. So there's going to be, unless you have your fancy TI, whatever that is, calculator that engineering students have or math people. You would do cube calculator, and you suppose the code behind the cube calculator here is any different than what we just did? Nope. Oh. Okay, well, I want a cube. There we go. So we want 10, right? Calculate. Frog goes wild. Right? And that map behind this is no different than what we just did. It's just on a website. Code's going to be the same. Now we have our answer. We know our calculation is good. How do we, eventually we're going to want to return the results of the calculation down here. But can I get the volume from down here? Can I put together an F string and include volume? How do I access this volume variable from my string representation? We'll just say message. And then to return that, we're going to return the message. I don't know, that's not a good name, but that's how you return it. How do we get a hold of this value? Over here in another part of our class. What binds a variable to the class? Starts with an S.
Oh, I think you had it.
Just say it. If you have it wrong, that's fine. Doesn't matter. If you don't get the right answer, we'll just laugh at you. No.
Kid. Kid.
What allows me to access edge.length from anywhere inside my class?
So,
That's the thing that binds everything together. With self on here, I can now access this. I can't do it like that, can I? Self connects it and makes it part of the object. Now I can access it from anywhere. I can put in self.volume. And there I am. Everything's happy. And add in some text, the volume is whatever. And then I print the cube. When you print an object, it uses this method. We return, I don't know, message, I just couldn't think of anything else to say there. Results, that would have been better, right? Results. That's better. Now, when I go through this, is this going to work? Sure. Maybe. Oh. Do we know it worked? Let's find out. Hopefully I kept my website open. Ah, I did. There it is. Of course, if this website's wrong, then what do we do? 12.3. What do you think? They're rounding it off and I'm not rounding it off, but same number. I don't think we need that many degrees of accuracy, probably. Comma, period, 2F. Yeah, I think that's it. Gives us a colon means that there's formatting coming up. Comma means if we're over 1,000, we get a comma separator. .2 means that we're only going to display 2 decimal points and we have a float value. Did what I do make any sense as to the logic? And it's not solving this problem that's important. I've been using this same process all semester. You know, figuring it out one little thing at a time. You're giving me the eye there, Eliza. Well, it takes time. You can't expect to become an expert programmer overnight.